Greetings, I'm Squared here today, and we're going to talk about factoring by grouping. So factoring by grouping is most often discovered which way you're going to use it because there are 4 terms. Sometimes there can be more, but at the beginning level of Algebra 1, there will only be 4 terms. So that's how you can tell. Remember, the first step is always the greatest common factor. If it's a binomial, we check for a difference of 2 squares. If it's a trinomial, we check for trinomial squares first because that makes it easier. After that, we have to use our box method or whichever way you use. And if it's got 4 terms, we're always going to try grouping. Now, some people might have already been doing the grouping method because that's how the book has been showing it online. But if you haven't, then this is how we do it. The first thing we do is recognize that there are 4 terms. Then we take the greatest common factor out of the first 2 only, and then we take the greatest common factor out of the last 2 terms only. And again, they probably won't make you switch terms around, but at the next level, sometimes you have to move 2 terms around in order to get it to work. But at this level, we're not going to do that. I might show you an example of that. But then you look at what's inside the parentheses, and it should be the same. There's going to be 2 sets of parentheses because we took the greatest common factor out twice. And then we factor out the greatest common factor, which will be the thing in the parentheses, and then we end up with the product of 2 binomials. So let's do it. Okay, first step. What's the greatest common factor of the first 2? It's 4. So we're going to factor out a 4 of just the first 2. The greatest common factor of the last 2 is 6x, so we're going to factor out a 6x. So we're going to get an x minus 2m. Notice that we have the same thing in parentheses. So what we really have here is a 4 times x minus 2m plus 6x times x minus 2m. And since the same thing is in parentheses, that's our new greatest common factor between these 2 things. So we factor out our new greatest common factor. And what's left here is a 4 and a 6x. And now we have 2 binomials that multiply together to equal our 4-termed polynomial in the top. We can always check it. There's a 4x, right? There's a 6x squared. There's my negative 8m. And here's my negative 12mx. So check it. It all works out. Okay. On to this one. So we look at the first 2 factors and the first 2 terms and the last 2 terms. So the greatest common factor of the first 2 is a 12u, and what would be left would be a v minus 12 goes into there 6 times. And what's the greatest common factor there? Is, oh, I forgot there was a u left. There's an 8. And what's left when I divide both of those by 8 is a v minus 6u. And I kind of did that step up there. And I forgot to put the 12u there. So we're going to write it all down. 12u times v minus 6u plus 8 times v minus 6u. Notice that the same exact thing is in parentheses. So that becomes my new greatest common factor. And I write it like this, and I am done. Okay, we'll do a few more examples. Here we go. Greatest common factor, 7x squared. Greatest common factor, negative 2. Right? Both of those are even. Since they both had a negative, I took out a negative. What's left in this one? 7x plus 5. And what's left in this parentheses when I divide both of those by a negative 2? Watch your signs there. 7x plus, because I took out a negative 5. You can always double check. Does negative 2 times 7x get me negative 14x? Yes. Does negative 2 times 5 get me a negative 10? Yes. And of course you want the same thing in the parentheses. So I take out my greatest common factor, and I see what's left to get my second binomial. All right, on to the next one. Greatest common factor, v squared. Greatest common factor. Okay, so now that was a positive and a negative, and this one's a negative and a positive. So what I want to do probably is take out a negative 4, because then that'll get me a negative in the middle, just like that one. So let's see if that works. So if I divide everything by v squared, I get 3v minus 2. And over here, if I take out a 4, I get 3v minus 2. So my 3v minus 2 becomes my greatest common factor of those two parts, and I get a v squared minus 4. Now here is the tricky part. You need to be able to recognize if your binomial is a difference of squares. This is a difference of squares. So I need to keep going. Whoops, excuse me there. Down here, 3v minus 2. A difference of squares means I have a v plus 2 and a v minus 2. Remember, we take the square root of both of those. One time we get a plus 2, one time we get a minus 2, because v times v is v squared. I get 2v minus 2v when I do my inners and my outers, and 2v minus 2v gets me my 0v. Notice there's no v's. And then 2 times negative 2 gets me my negative 4. So this is the answer. Tricky. Sometimes there's more to do after you do a little bit. Okay, greatest common factor between these two? I have no idea, so I would take I'm not seeing the 85. 85 is 5 times what? So I take 85 divided by 5, and I get 17. Okay, there is no greatest common factor there. I'm wondering if I did that incorrectly. So we're going to call that prime. There's no greatest common factor here. There's a 3 here, right? And sometimes you might have a prime. There's no 3 there. If this was something different, there's an x squared, right? We can take an x squared out, I suppose. Let's take an x squared out. And we get 24x plus 85. Those aren't the same. So then we just say, oops, okay, that doesn't work. That's prime. All right, and on this one, let's find our greatest common factor. Here, it's 5y squared. And here, negative 8. And if I divide both of those by 5y squared, I get y plus 3. If I divide both of those by negative 8, I get y plus 3. Y plus 3 is my greatest common factor. And I get 5y squared minus 8 as my second binomial. All right, that's factoring by grouping. So good luck with that. Just follow those beautiful steps I gave you at the beginning. Those are your steps, and you'll be golden every time. M squared signing out.